Hi, I'm Greg Katie. I'm going to talk to you today about lithium batteries. Okay, so uh, we'll talk a little bit about um, what is a battery, why is it important to us in modern society in America, what their role is. We'll talk about the history of batteries, the technology that existed before 2000 and after 2000. Um, we'll talk about lithium mining a little bit and talk about different lithium battery technologies of the future. At the end, I'm going to show a little video of some solar projects we've done here at our farm using lithium batteries and solar. Okay, so history of batteries. What's a battery? It's something that's used to store chemical energy and convert it into electrical energy. It's used to power electrical devices. Modern batteries allow us to use portable backup and emergency power. We use them in vehicles. They help reduce the reliance on fossil fuels, and they're a key component of our renewable energy future. I learned about this in the video the other day, but the voltaic pile was the first, thought of as the first battery. In the year 1800, Alessandro Volta used discs of zinc and copper and a brine-soaked kind of cardboard material to produce the first continuous electric current. People could get bursts of electricity before, but this was kind of the first continuous current, and it's used the kind of the foundation for modern electrochemistry and battery technology. Later scientists such as rockstar Humphrey Davy used the continuous flow of electricity to discover new elements. And Volta was honored by having the electrical unit, the Volt, named after him in the year 1881 by the International Electrical Congress in Paris. So before the year 2000, lead acid batteries were, and they still continue to be, an important battery technology. First developed in 1859 by French scientist Gaston Planté. They used lead dioxide as a positive electrode and a sponge lead as a negative electrode with sulfuric acid as an electrolyte solution. It's just rechargeable through chemical reactions that were reversible. Some of the advantages are its low manufacturing costs, high surge current to use for starting vehicle engines, high rate of recyclability. 95% of the lead in the batteries can be recovered. Some of the disadvantages, of course, that lead is toxic, and as well as the sulfuric acid is corrosive. They're heavy and they have a lower energy density than some of the newer battery types. They're used in cars, power supplies, backup systems, forklifts, golf carts, and key pieces of importance were that it was the first kind of rechargeable battery. It's still a widely used battery technology 160 years later. Um, Before 2000 as well, the nickel cadmium battery was discovered in 1899 by Swedish scientist Valdemar Junger. Uses nickel oxide hydroxide as a positive electrode and cadmium as a negative electrode, and a potassium hydroxide solution as a electrolyte. It's rechargeable hundreds or thousands of times, performs extremely well under extreme temperatures, and delivers current quickly. Long service life, durable construction. However, cadmium is another toxic element. It does have a lower energy density than some of the newer technologies, and there's a memory effect issue where if it's partially recharged, it reduces the capacity of the battery. It was one of the first successful rechargeable batteries for portable applications and helped expand the use of cordless electronic devices in the early 20th century. Nickel metal hydride is another battery technology developed in 1989 by several businesses, similar to nickel cadmium, but the cadmium that was toxic is replaced by a hydrogen absorbing metal alloy, and it uses nickel oxide hydroxide as an electrode. 30 to 50% higher energy capacity than nickel cadmium batteries, safer, and it's less prone to that memory effect that we spoke about. There is a higher discharge rate than the nickel cadmium, and it did generate some heat while it was being charged. They're used in rechargeable AA and AAA batteries, digital cameras, cordless phones, and even some of the first Toyota Prius hybrid vehicle generations were using the nickel metal hydride batteries. It's kind of thought of as a bridge between the nickel cadmium batteries and now the modern lithium batteries. So lithium ion technology became the dominant rechargeable battery. It was driven by smartphones, laptops, electric vehicles, and continuous improvements in lifespan and charging speed and cost, seeing a pretty rapid adoption amongst different technologies. It revolutionized energy storage, and it was first made commercially by Sony, the company Sony, in 1991. And here are some modern lithium battery chemistries. We'll talk a little bit about what I use is here at the farm is the lithium iron phosphate battery. It's safer and longer life than lead acid batteries, at least, and lighter weight. It used in electric vehicles and for solar storage. Lithium, nickel, manganese, cobalt oxide batteries, that's a mouthful, NMC, are used in most electric vehicles. They have a key strength of being at pretty balanced performance, whereas the lithium, nickel, cobalt, aluminum oxide batteries, NCA, are what they use in Teslas. This is the highest energy density, and that technology is really taken off. There's a couple other different technologies on the screen here for different applications. The next generation of lithium batteries include solid state batteries, which are promising improved safety and higher energy densities. And then they're also developing sodium ion batteries, which replaces the lithium with a more abundant sodium. The new trend of massive battery manufacturing facilities are known as gigafactories, and they're expanding worldwide. And because there's such demand for electric vehicles and other large-scale solar storage systems, and that will help stabilize our electrical grids and store the electrical energy. Okay, so let's talk a little bit about how lithium is mined. The most common method is brine mining, where lithium water that has a high concentration of lithium is was removed from groundwater reservoirs, pumped into evaporation ponds, where it's then left for months or even years to evaporate out the water. Lithium gets concentrated and is further processed. It leaves these lithium salts, and the salts are refined and processed to different compounds that will then be used, like I said, for smartphones and laptops and electric vehicles and so on. Some of the challenges of the lithium mining is that it does alter the landscape significantly. With these massive ponds, there's danger of pumping too much groundwater, the strain on water supplies in arid regions where a lot of these take place. There's the most abundant lithium is mined in what they call the lithium triangle, which is in Chile, Argentina, and Bolivia. But the current emphasis is on more sustainable mining practices that improve water management and explore other extraction technologies. So there's not all these really negative environmental side effects due to mining. The chemical processing part is where the lithium is converted to usable form. So the brine is used at a processing plant. Chemicals are added. The impurities such as magnesium and calcium are removed through precipitation reactions, and they use sodium carbonate to add to the purified brine, and this causes the lithium ions to react and form lithium carbonate, which precipitates out of solution, and then this is the reaction you have. The solid lithium carbonate is filtered, washed, and dried, and it produces a high purity product. The future role, it's not just only lithium iron phosphate, which is what this picture depicts here, but the improved energy density will increase and in storage capacity and range of the different lithium technologies. They're aiming to develop faster charging technologies so that your smartphone charges in minutes rather than hours. And batteries will continue to play a crucial role in the electrification of transportation, integration of renewable energy sources, and the transition to a cleaner and more sustainable energy future. So, summary, the modern battery technology is rapidly advancing. The new technologies promise greater storage potential, lower costs, improved safety, and kind of a different aim for environmental friendly techniques in mining and extraction and recycling. There's a growing demand for electric vehicles and renewable energy storage for solar and wind power. The demand increases, more and more as we look at climate change and try to get away from fossil fuel energy sources. While lithium is a finite resource, it's not scarce. There's thought that while the mine's expensive, technologies are improving, and lithium recycling has a lot of potential of taking used batteries and recycling that majority of that lithium for the next generation of batteries. Future developments are going to focus more on performance of batteries and reducing their environmental impacts. The competition of new technologies like sodium-ion batteries are going to give it a run for its money because they're using more abundant and less expensive materials. But lithium batteries are expected to be the preferred choice for applications requiring high energy density, such as EVs and portable electronics. So that was the presentation. Thanks for watching. We're going to end with a couple videos of just a couple projects we did at the farm, messing around with solar and kind of having fun with it. Thanks for watching. Okay, here's the solar Handtruck system that I just built today. I have a 12 volts, 100 watt solar panel. And this is right now a 12 volt lead acid battery. I'm going to switch it back to my lithium one. The voltages work the same. The difference is you don't want to draw a 12 volt lead acid battery all the way down. It will damage it. But the advantage of lithium ones is you can draw them down to 0% and you still get 1,000 cycles. Right now I'm pushing 14.9 volts, 5.5 amps from the solar panel, not very much sun. So the 12 volt battery goes to this charge controller. This is the battery, and then this goes to my panel, and then the battery has wires going to this inverter, which is a 1,000 watt inverter that will convert back that DC power, 12 volt DC, to 120 volt, 60 hertz AC power. So I can take any regular size plug, put it in there as long as it's under 1,000 watts, which most things will be. On the top I just have a little Bluetooth connection for my phone to tell me the status of the charger. Okay, then over here we have the eGator that I got from Miramar College at auction, and I took the 6 volt, no, it was 6 volt batteries in here, lead acid, that were a couple 100 pounds, and replace it with this one. This is only like a 20 amp hour 48 volt battery. And the way this works is I have the battery connected to the eGator, this John Deere eGator, and this is a boost solar charge controller which takes, so I'll drop this down here. My solar panel in the back is a 24 volt solar panel that normally wouldn't charge a 48 volt battery, but with the boost it will bump that charge up to above 48 volts. You need to have a higher voltage to charge the battery, and basically this thing never gets plugged in. I put in a little switch here to see my status, 52.5 volts, and that's plenty of juice for me to get around our property here. Pretty cool. Okay, so welcome to the hoop house, where we got some cucumbers and salad and tomatoes growing. I'll show you the setup I have built this last weekend. The whole purpose of this is to power my greenhouse exhaust fan, hooked up to this controller here, thermostat. I have it set at 82 degrees. I don't know if you can see that, to exhaust the hot air that gathers at the top. Right now we're brewing a little compost tea, but the setup is from the solar panel. We're coming in down here through the conduit up to a shutoff for emergencies. I can kill the power for the solar. This is feeding into my charge controller, which is up to 100 volts, 20 amps. The 12 volt solar panel, 200 watts, I think peaks around 10 to 12 amps, so that's sufficient there. The battery down here is my 100 amp hour 12 volt lithium battery, which seems to be plenty to power. And then from the battery, this is my inverter that will take the DC power back to AC to feed to power the fan. I think this runs about 85 watts, and this is a 500 watt inverter, so plenty of juice here. This little pump is probably only 5 or 10 watts. So this is enough for me throughout the day to power the fan when it gets hot enough. Usually holds up. Sometimes I've had some problems with the fan wanting to go off due to high humidity. It's just based on this kind of cheap brand that I bought. But so far it's worked. I did have to upgrade from a 100 watt solar panel to a 200 watt solar panel. It was killing the battery throughout the day on the really hot days. Just kept the fan going, and was using all the power to power the fan and not actually charging the solar panel. So sometimes in the afternoon and the evening it would get pretty hot in here, and I'd have to just switch out the battery for a temporary solution until I upgraded to the 200 watt panel. Okay, I mentioned that compost tea. I didn't really explain what it is for the gardeners out there. What I do is I have worm castings and some good dairy manure compost that I have in this, basically this tea bag with these air stones. They're just little bubblers, and water. Some people add other ingredients to it, but basically what I'm doing is trying to multiply the beneficial microbes, some growing microbes, that I then will put in a watering can and pour on the plants and feed the soil. The whole idea is this beneficial fungi and bacteria are going to help make nutrients available for the vegetables I grow.